Okay, we are doing lesson 2.6. Sorry again, I'm not here. I know this has been a horrible week. I've just got to get all these doctor's appointments in for my car accident. Hopefully this is going to be the last one till my shoulder surgery. So hopefully. Okay, today we are going to be doing 2.6, and this is going to be pretty much the opposite of what yesterday was. Okay, so let me share my screen. We're going to go to the PowerPoint. Share. And sorry, I'd kind of gone through it. So let me get back to the beginning. So we're going to be, yesterday we had the boundary line value and we found the area. Today we're going to be given the area and finding the boundary line formula. And then there's going to be some instances where I'm giving you the area, maybe I give you the mean, and they're asking what the standard deviation is. Okay. So then we're going to be doing that one. There you're going to have to do a little math. So let's start first. We're back with our Gary, Indiana. Again, our mean is 6.84. Our standard deviation is 1.5. And especially on this lesson, I would have a sheet of paper and I would start writing that stuff down. That way you're not going back and forth between the applet. Now, the question here is for these students, what would be the score you'd have to get to be at the 90th percentile? Meaning your score was better than 90% of the students that took it, or 10% less than the highest one. Okay, 10% did better than you. So what this is going to translate to is 90th percentile means that area under the curve here is 90% or 0.90. Okay, we don't leave it as 90%. We got to make it that decimal, 0.90. Okay, so what are we going to do with this? Okay, we need to do the opposite of what we did yesterday. And again, can you use a table? Sure, we're not going to. Okay, because you got to find the one that corresponds the closest to 0.90, blah, 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 blah. Okay, then we're going to use this formula. Now, this formula is going to be important because we're going to have to use it later. Okay. So here's how we're going to do it. I'm skipping this one too. This is using z-scores, standardized. We're going straight to here. So you're going to go to StatMedic. And when you get to this drop-down menu, okay, we have been doing find the area that corresponds to a value. We want to do the second one in this drop-down menu. We want to find what that value is that corresponds to the area of 0.90. So you're going to put in your mean of 6.84, your standard deviation, then you click plot distribution. Okay. This is our 90%, our 0.90. So we want the area to the left. This is what we're trying to figure out. Where is this boundary line? So it's left tail with an area of 0.90. And when you click calculate the value, you can see that score needs to be an 8.826. Now on our StatMedic, it's not here. You're also going to get a z-score. And if I were you, I would write that z-score down. Okay, I'd get in the habit, write that value down, also write that z-score down, because some of the problems in your assignment are going to need that z-score. And so that just kind of saves you trouble of going back and doing it again. Okay, so this is all we have to do. When you're given the area, we've got to use that second option in that drop-down menu on operation, calculate the value to an area, put in your mean, put in your standard deviation. You just got to make sure a left tail, you know what that percentage is, 0.90, and hit calculate. It's kind of nice. Yeah. Like StatMedic. Okay. This is the same as yesterday. You might need to draw it out like I did up on the board and figure out, is it right tail or left tail? Perform your calculations, show your work. Well, okay, well, I'll show you how to key it in StatMedic. Now, college, you might have to show your work, but for me, I'm good. Okay, so here's our stop the car example. Okay, so I immediately go through this again, and I'm like, my mean is 165. I'm writing it down. My standard deviation is 4 feet. Now I'm going to look at what question they're asking. And they're saying 1% of all emergency stops take more than what distance? So I could reword that and say, what is the distance? Okay, what's the boundary line? That distance where only 1% are to the right of it. Okay. So now if we do this, I want you to think about that. Okay. When we draw it, that 1% is here. We're like, okay, what is the boundary line where 1% is greater than that? If 1% is greater, then that means 99% is less. We're going to use this 99, okay? Because if 1% is more than this distance, that means 99 is less than this, okay? So here's what we're going to do. And I'm writing down now. My area is 0.99 because 99% is to the left. I'm going to go in StatMedic, okay? And let me see if I can pull this up. Sorry, PowerPoint does not let me flip back and forth really, really easily. Excuse me. So I'm going to share my screen. I'm going in here to StatMedic. And I've got this really, really blown up. Why is my screen sharing paused? Okay, so here, I'm going to do my drop-down menu. I'm doing the second one. We've got a mean of what? 165, a standard deviation of 4, plot my distribution, left tail, and the area is 0.99. And so here's where I calculate the value. And again, is there a z-score down here? Yes. So at 174.305 feet, 1% of all emergency stops needed more than that. Okay? So that's what we're going to do. There's my answer. Now let's go back to the PowerPoint. Okay. And so here they're doing the table. They're doing all this crazy stuff. We're not going to do the table. We're going to do what I just did. And look, isn't that the exact same answer I just got? At 174.32 feet, 1% needed more than that. Okay. And you would interpret it by saying 1% of emergency stops needed more than 174.3 feet. Okay. So now, is it possible to find the mean or the standard deviation? This one is where it's just a little bit harder. So this is where that z-score is going to come into play. Okay. So let's look at our example here where we've got data for 7-year-old girls. And again, I'm on my sheet of paper here now. I'm writing the mean is 48 inches. It's the 90th percentile. So area is 0.90. And at the area at 0.90, that X value, that boundary line is equal to 51. Okay. So they're wanting us to find the standard deviation. Here's where you're going to have to remember a formula. You have got to remember that the formula is the z-score formula. And if we look here, our average is 48. Here's our boundary line at 51. 90% are below that. Okay. So here's what we're going to have to do. We've got to get a z-score. Okay. We've got to get a z-score. I cannot go in and calculate the z-score easily just because I don't know standard deviation. Everything we've been doing, you've needed the mean and you've needed the standard deviation. We do not have that. So what we're going to have to do in StatMedic is something a little different to find it, okay? So let's go in StatMedic. When we are trying to find this z-score, you are going to have to calculate it. Why is my screen sharing paused? I don't understand why it says paused. Let me try it again, okay? Let me see if I can get back to this again. StatMedic. It's pausing it again. I do not understand why this is happening. Sorry about this, guys. I know y'all want to get done quick, but this is going to help if I can share and I can show it to you. Okay, so let's see if now, here we go. Okay, yay. So what you're going to do here, okay, we are going to go back to calculating the area under the normal curve. Okay. Oh, no, sorry. We're not calculating the area of a corresponding area because we have the area. Now, because we don't have mean and standard deviation, we don't. All I've got is the mean. I need standard deviation to do this with unstandardized scores. I'm going to have to use standardized scores. And you just need to remember this. When you can't answer both those questions, your mean is going to be 0 and your standard deviation is 1. Okay? These are standardized scores. And in standardized scores, the mean is always 0, standard deviation is 1. So we want the value underneath it, and that area is, it told us 90%. Calculate the value. Do we have this z-score down here? You see the value is the same thing as the z-score because our mean is 0 and standard deviation is 1. So I'm now going to write down that z-score, 1.282. Okay? This is how you're going to find that z-score. Now I'm going to go back. Okay? I'm going to do a whiteboard for you here. Okay? So what we're going to have to do now is you're going to have to use the formula that z is equal to x minus mu. That's a horrible mu over standard deviation. And they're asking us, what is this standard deviation? So let's plug everything in. Z was 1.282. God, this is so horrible. X, we know that was 51 because at 51, that's 90%. Our mean is 48. Plug that in. And I don't know what the standard deviation is. So now you just do the math on that. Okay, 51 minus 48 is 3. And I can tell you, I've just done this enough that when you have the variable in the bottom, if you just will swap these two, you get the right answer. You do 51 minus 48, which is 3, divide 3 by 1.282, you have your new standard deviation. Okay? Yeah, pretty cool on that. All right. Back to the PowerPoint. Okay, I'm going to leave it like this so it'll be easier to get out of it. And again, that's what we found, 1.282. Use that for your standard deviation. And then we end up finding out that 3 divided by 1.28 is 2.34 inches. Okay? And that's our answer. Now, again, you're going to need to know this formula. Z equals x minus the mean divided by standard deviation. Because you're going to need the z-score, the mean, and or x and your mean if you're solving for standard deviation. If you're solving for the mean, then you're going to have the z-score, the x, and the standard deviation. Or you could be right here, okay? If you didn't know the mean or the standard deviation, you're going to have to do a system of equations. You're going to have 2 equations for 2 unknowns. Hopefully, we're not going to have to do that. I haven't had to do that. Working the homework, I didn't have to do that. So just know that's what you'd have to do. All right, so did we talk about finding that value that corresponds? Yes. And then the mean and the standard deviation? Yes. Now, I will tell you when you go to the assignment, I think it's number 4. When I got the z-score, it was like 3 decimal places, and the answer was coming up wrong. The book is going to want you to take that z-score to 2 decimal places. Yeah, and that's where it was coming out really, really wrong. There can be some rounding errors with this one. It's weird. I hate that about this textbook, but if you've got some rounding errors, just like round things different, maybe shorten them to 2 decimal places and see what number you get there. If you have any questions, just hit me up on Google Classroom, and hopefully in between, like in the lobby and stuff, I can try to answer those questions. But 2.6 is key. It will be due on Monday. Monday we'll be doing review, and Tuesday we'll be taking Chapter 2 test. So hope everybody has an amazing weekend. Hope the football team wins tonight, and see you on Monday.